Hello everyone. Welcome to Online Teaching with Shri, where we learn maths the smart way.
Hello everyone, welcome back to my YouTube channel. In this video, we are going to discuss question number 2 from exercise 1.1 of the chapter Real Numbers. In this question, we will learn how to find HCF and LCM of the given pair of integers using the prime factorization method. So without wasting any time, let's get started. Let me read out the question. Question 2 says, find the LCM and HCF of the following pairs of integers and verify that LCM into HCF is equal to product of the two numbers. Okay. So, I will tell you 4 steps to be followed for this question. The first step is we have to find out the prime factors of both the given pair of integers. Okay, the first step is factorization. Factorize both the numbers 26 as well as 91. And the second step is find the LCM. LCM means the least common multiple of 26 and 91 and the highest common factor, that is HCF of both 26 and 91. And the fourth step is, according to the question, they are saying verify that LCM into HCF equals to the product of the two numbers. So the last step should be we have to find the product of LCM and HCF. Whatever the value we will get from this, we have to multiply that and check whether it is equal to the product of the two numbers. Here product of the two numbers means 26 into 91. Whether this is equal or not, we have to verify this. If it is equal, then we have to say verified. Okay. Shall we start solving this now? Yeah. The first step is I need to find out the prime factors of 26, right? So which is the first prime number? The first prime number is 2. Can I divide this by 2? Yes, I can divide this by 2 because 26 is an even number. 2 ones are 2 threes are. Next, 13 is the prime number. So I should divide this by 13 itself. It doesn't divide by any other number other than 1 and 13. So I am dividing this by 13 directly. So if I express 26 as, can I express 26 as 2 into 13? 2 and 13 are the prime factors of 26. So I am expressing this like that. Okay. Next, which is the second number? The second number is 91. Can I divide this 91 by 2? No, I cannot divide this 91 by 2 because 91 is an odd number. So can I divide this by 3? No, I cannot even divide this by 3 because 91 is not completely divisible by 3. I have already made a video how to check whether a number is completely divisible by 3 or not. Please go and check it out that first. I will be providing the link in the description box. Next, which is the next prime number? 5. No, I cannot even divide this by 5. Then which is the next prime number? Yes, I can divide this by 7. 7 ones are 7, 7 threes are 21. This 13 is a prime number, so 13 ones are 13. Okay, now I got the prime factors of 91, 7 and 13. Now I am going to express 91 as 91 equals to 7 into 13. Okay, yes. What is the next step? Next step is to find out the LCM and HCF. How to find out the LCM? To find the LCM, we take all the prime factors appearing in both the numbers with their highest power. Okay, so my LCM will be equals to 2 into 2 into 7 into 7 into 13. So 13 is appearing in both the numbers 26 as well as 91. The highest power here is 1. Here the highest power is 1. In both the numbers the highest power of 13 is 1. So I am taking 13 power 1. 13 power 1 means it's 13. Okay. So now the product is going to be 182. If you calculate 2 into 7 into 13, you will get the value as 182. Okay, similarly, now we have to find out the HCF of these two numbers. How to find the HCF? How to find the HCF? To find the HCF, we'll look for the common prime factors present in both the numbers. So in this case, which is the common prime factor present in both the numbers? 13. 13 is the prime factor which is common in both the numbers 26 and 91. So my HCF is going to be 13. Okay, yes, we have factorized this and we have found out the LCM and HCF. What is the next step? The next step is to check the product of the LCM with the product of LCM and HCF with the product of the two numbers. So now we have to find out the product of LCM and HCF. What is the value of LCM? 182. 182 into HCF is 13. 182 into 13 will give you, if you calculate this, it will give you 2366. Okay. Now we have to find out the product of two numbers, these two numbers, 26 and 91. When you calculate 26 into 91, you will again get 2366. Both the values are same, so we can say that verified. Hence verified. Okay. Now shall we move to the second one? Yes. Second one. Second is 510 and 92. What is the first step? We have to find out the prime factors for both the numbers. Okay. 2, 2 twos are 2 fives are 2 fives are. Okay. Next. Is this divisible by 2 again? No, because this is an odd number. And is this divisible by 3? Let me check. 2 plus 5. 2 plus 5 is 7. 7 plus 5 is 12. Is 12 divisible by 3? Yes, 12 is divisible by 3. That means 255 is divisible by 3. 3 8s are 24. 3 5s are 15. Next. Is this divisible by 5? Yes, because the last digit is ending with 5. So 5 ones are 5. 5 sevens are 35. Next. This 17 is the prime number. So I am going to divide this 17 by 17 itself. 17 ones are 17. Okay. Now I got the prime factors for 510. Similarly, let me find out the prime factors for the number 92. Okay. Yes. Can I divide this by 2? Yes. 2 is a prime number and 92 is the even number. 2 8s, 2 4s are 2 6s are. Next. 2 2s are 2 3s are. Okay. Next. 23 is a prime number. So I am going to divide this 23 by 23 itself. Okay. Yes. 23 ones are 23. Now I found out the prime factors for 92. Okay. Now can I express 510 as 2 into 3 into 5 into 17 and 92 as 2 into 2 into 23. Can I write this as 2 to the power 2 into 23? Yes, we can write like that. Okay. Now, the next step is we have to find out the LCM. LCM will be equals to, so 2 is common, yes, but the highest power of 2 is 2. So we have to consider this 2 to the power 2 into 3 into 5 into 17 into 23. Okay, so this is going to be to 23,460 LCM equals to HCF will be equals to what are all the common factors present in both 510 and 92 is 2 2 into only 2 is present, so HCF is equals to 2. Okay, now what is the third step? We have to find out the product of LCM and HCF. So product of LCM and HCF will be equals to LCM into HCF equals to LCF is how much? 23,460 into, and HCF is 2. So this is going to be 46,920. Now we have to find out the product. Now we have to find out the product of these two numbers, 510 into 92. 510 into 92, when you calculate this, it is going to be 46,920 again. So both the numbers are same. The product of the given pair of integer is equal to the product of the LCM and HCF of the given pair of integer. Hence it is verified. Okay. Shall we move to the third one? Yeah. Third one is 336 and 54. Okay, so which number I should take to divide 336 first? 2. Okay, 2 ones are 2, 2 6 are 12, 2 8s are 16. Next, 2 8s are 16 and 2 4s are 8. Next, again this is divisible by 2. 2 4s are 2 2s are 2 2s are 2 1s are. Next, is this divisible by 2 again? No. 21 is an odd number. So, is this divisible by 3? Yes, because 2 plus 1 is 3. 3 is divisible by 3. That means 21 is also divisible by 3. 3 sevens are 21. Next, 7 is a prime number. So, I am going to divide this 7 by 7 itself. 7 ones are 7. So, now I got the prime factors for 336. Similarly, I am going to find out the prime factors for 54. 2 2s are 2 7s are 14. Next, is this divisible by 2? No. Is this divisible by 3? Yes. Because 2 plus 7 is 9. 9 is divisible by 3. That means 21 is also divisible by 3. 3 1s are 3 9s are 3 9s are 27. Next, 3 3s are 9. Next, 3 1s are 3. Okay, now I got the prime factors for 54 also. Okay, now I am going to express the number 336 as the product of its prime factors. That is going to be 2 into 2 into 2 into 2. 4 times 2, 1, 2, 3, 4. Yeah, into 3 into 7. Okay, and can I express this as 2 to the power 4 into 3 into 7? Yes, because I am multiplying this 2 4 times, right? Instead of that, I can write 2 to the power 4. Next, 54 can be expressed as 2 into 3 into 3 into 3. 2 into 3 into 3 into 3. Can I write this as 2 into 3 to the power 3? Yes. Okay, yeah. Now I'm going to find out the HCF and LCF. HCF means the highest common factors. That means we have to write only the common factors present in both the number. The common factor present in both the number means here 2 to the power 4 is there. But here only 2 to the power 1 is there. Which is the common then? 2 to the power is common. 2 to the power 1 means 2 into, here 3 to the power 1 is there. Here 3 to the power 3 is there. Which is common? 3 to the power 1 is common. Correct. So 3 to the power 1 means 3. Here 7 to the power 1 is there, but here 7 is not there. So my HCF is going to be 2 into 3. But how about my LCM? My LCM is going to be, I have to consider the highest. I should consider the highest power number. So I should consider 2 to the power 4 into, here I should consider 3 to the power 3. Between 3 to the power 1 and 3 to the power 3, I should consider 3 to the power 3, the highest power number. Okay, and then here 7 to the power 1 is there. Here 7 to the power 0, 1. 7 to the power, any number, if you take any number, maybe 7 to the power 0. Okay, anything power 0 is going to be 1. So here I should take 7 because it is having 7 to the power 1 and it is having 7 to the power 0. 7 to the power 0 means 1. So my LCM is going to be this much, 2 to the power 4. 2 to the power 4 means multiply 2 4 times, and 3 to the power 3 means multiply 3 3 times, and then 7. Okay, so my HCF is going to be 6. My LCM is going to be 3024. 3024. 3024. Okay. Yes. Now, what is the next step? I have to find out the HCF into LCM. HCF into LCM is going to be, when you multiply both these numbers 6 and 3024, you will get 18144, 18,144. Okay, and what is the next step? We have to verify this with product of the number. So product of the number means 336 into 54. After the calculation, again you will get 18,144. Hence we can say that this is verified because the product of the HCF and LCM is equal to the product of the
Thank you for
given
watching.
pair of
If you found this
integers.
video
Hence
helpful, please don't
verified.
forget to like, share, and
Hence
subscribe to my
verified.
channel. Keep learning, keep practicing,
Okay.
and I'll see you in the next video.